you.
Yes.
Can you hear me? I think I can make myself. Okay, good. Actually, I'm going to take you guys out of the bench tops to the desk tops. So I'm not going to talk much about experiments, or I'm not going to talk about experiments. Actually, my interest is creating a kind of awareness about terminology and things that are happening and the situations we are facing after recent events regarding bioterrorism and viruses. The reality is that we live in a globalization time, and we just saw an example about zucchini moving now back from agriculture to ecosystem. In the past, we thought that the things were raining from the ecosystem. And the other thing is that there are some new sources, and they are very active. It has to do with the human spreading of all kinds of organisms, not only viruses. And we used to talk about natural distribution, natural migration, and this is a classical movement, but now we have a very active, if you check the amount of merchandise and goods that are moving worldwide, and ornamental, and many other things that are moving, then we go and we go to the new scenario in which we are talking now about invasive species, naturalization, receiving ecosystems, and all what is going on in here, in the biological invasions and all of this. So I'm going to take this to the overlapping areas of new disciplines, and microbial forensic is one of them. As we saw yesterday, is about attribution, is about a legal frame and high-tech laboratory services. So this microbial forensic is demanding accredited certified lab, something that we don't use in sciences to do. And it's a very strict legal frame. You cannot go around and picking samples like that. It's just because the samples require a chain of custody. And well, the whole investigation is about determining from where the things are coming from and the pathways that were used or introduced illegally or illegally. And then we find biosafety, which is something that not many people follow exactly in our research labs. But it's about minimizing science accidents, avoiding escapes, exposure, human exposure to dangerous things, following guidelines and training, keeping things, people, doing the things in the right thing. And microbial forensics depend heavily on this. These guidelines are very important because the lab has to be accredited. So not every lab can do a test. If you want to do a test in this field, there are some labs that are going to do it. Government, whatever country it is going to pick them, select them. Then we have the other area, which is biosecurity. Biosecurity is about surveillance, policy, quarantine, response, remediation, a heavily background in science, because the people in biosecurity, wherever in the world, they believe that if all these policies are science, are very well documented and based on science, then things are going to work. And risk analysis with all the variance management and all the diagnostic forensics. So all of this is working together, because people in biosecurity is going to look at microbial forensics analysis. They are not going to look for other people doing the testing for that. Okay. And both of them rely on biosafety. Then we find the people working in food biosecurity and food biosafety, which they are quite independent, because it's a huge world. is a lot of pathways susceptible to anthropogenic intervention, criminal or not. And then you're finding here a lot of laboratory testing again, guidelines, biosafety things, accreditations, and basically the difference between food biosafety and food biosecurity is that food biosafety look for minimizing the intentional contamination, and the other, sorry, this is a mistake in here. This is the non-intentional, and this is the intentional. And then we find biodiversity, which is where all the things are coming from, and goes back to. And in here we find all possible living organisms in all the variants from genes to ecosystems, and all sources of good and bad guys. And in here we have to be very unbiased, because the tendency is that to see viruses as dangerous things. And of course, when we introduce organisms like the zucchini yellow to Costa Rica somehow, taking this example because it's fresh in our mind, and then seeing the zucchini going back to nature and invading some other species, then you have to look at the consequences and the change in evolution that is going to happen there in the years to come. So we're having here multiple disciplines, single arena, and similar functions. And we as a scientists need to know where we fit in there. In the 60s, the triangle of disease was proposed by Stevens, and we thought that environment, disease, pathogen, host was all about, but later on we knew that they were vectors and that the time was very important, and that the insect vectors were playing a very important role there. So we found that nature, things were coming from nature, biodiversity was there. And then we were talking about the microbe world and the biodiversity there. And now we have a new definition made by governments. In the United States it's called select agents, but in many other countries are called high impact pathogens. And select agents is an interesting definition because in there we have two elements, policy and biological. And so this definition is satisfying the two sectors, because scientists can talk about the biological properties of the microorganism, and at the same time policy people, government people can say, oh, that microorganism is also having some features because it's a high impact, it's creating a tremendous damage in the economy, it's creating a tremendous damage or impact, you know, in a good or in a sector. So this is what is select agents about. Microorganisms that have some biological characteristics, and at the same time they are able to create a chaos in the society or wherever they emerge or are introduced. And well, we keep moving, and then we see that in the past, the only pathway we were thinking about was about the natural migrations of all these microorganisms from natural biodiversity to the disease complex. But now we have all these anthropogenic ways to do that as well, from international trading to passenger traffic, and then we found in here bioterrorism. And this is very important because bioterrorism is today an important pathway, but it is not the only one, and we have to be aware about that. We have to keep in balance. And we find, for example, that through the mail, people is introducing more and moving more microorganisms daily rather than bioterrorism, and causing still more damage by moving infected seeds and things by mail or by FedEx. Well, whether climate change, germplasm, and more recently synthetic biology. There are people doing things in garages. My mom is one of them. and it's unbelievable because people in garages, they are very well documented. They are doing interesting science. They have home pages. You can visit them, And most of them, they know nothing or very little about biosafety and also about biosecurity. And they are dumping all the buffers, you know, just into sinks of their houses and creating issues. And we don't know the consequences. We will know this probably in 5 years. So we have biology on the other side, generating an amount of data, biology with different disciplines, epidemiology, molecular biology, all possible disciplines are connected to biology, creating models, trying to understand how this is happening, predicting somehow. And all this information is a scientific input that is being taken by the policy people in government and biosafety people to write the guidelines and make decisions. And we are here. Most of us are here. So we are feeding policy somehow, and we are participating here. And this decision making has to do with quarantine, customs, pre-clearance, post-clearance, all the things that are happening at the airports when you are bothering those lines, and when you are trying to import a virus or asking the USDA a permit for having a virus in your lab, and all these things are happening here. And we have the border, which is not only the airport, but only the wharf, the ports, and many other things. And the reference diagnostic network that plays a very important role identifying new organisms, and every country has it. Oh well, most of the developed countries. And then you find in here, finally, biosecurity as the big pillar or the big umbrella on there, or is the whole monster of things. So biosecurity is about protecting human and animal health, plant health, agriculture, forestry, food, aquatic, which is actually very abandoned and neglected field of research for these kind of things, defense, justice, forensics. So biosecurity is about practically everything. It's not only about bioterrorism. Bioterrorism is a pathway that is introducing or can eventually introduce high impact pathogens of this group in here. And this is very important because we have been thinking that bioterrorism is about everything, and it's not. So we can here see just a cartoon, and you say, what is that? Well, this is a biosecurity system. And in here is what you can see. The port, the airport, the people checking, the people in the field taking samples and having surveillance, and the scientists taking samples, training, having meetings like us right now. And there is another platform on the ground, which is the people that is managing this kind of thing. Because this is the visible work. There is this other group doing management, planning, operations, and that is making all these programs, you know, to happen. And then we find the group that is the politics. It is a very heavy group in lobbies and things that have to do with all these things. So there is a vertical communication. We used to do horizontal communication among us, but there is a lot of vertical communication that we as a scientists can do as well, trying to support our programs in here. And we have to be aware of that. Now I'm going to show you some examples about viruses moving worldwide. One of the examples, probably a classic, is the citrus disease virus, aphid vector, and it's lethal in a man-made combination. I would say the canopy and the rooster, because this is a wedding that is a forced wedding. So the canopy is grafted on this rooster. The rooster has a hypersensitive reaction, and when the canopy get infected with the virus, and the virus translocates to the phloem and reach this line, there is a hypersensitive reaction in here. The sugars start accumulating because all these phloematic cells are dying, and then all the trees collapse and cause this quick decline disease. And this quick decline disease killed millions of trees during the 40s to the 80s in South America. But it's now not anymore a problem because in agriculture this has been substituted for tolerant rust ducts, and now this is what we see now, stampeding disease, and people can live with that. Another interesting study is pipino mosaic virus. This happened more recently, and it's a virus that was originally in Solanum muricatum. And Solanum muricatum is a solanum that produces an interesting fruit. It's a tasty fruit, and horticulturalists thought that having a plant looking like a potato but giving a fruit was an attractive new thing to have, you know, in the market. And then the plant was introduced from Peru to the Netherlands, and it's very well documented. In 1986, and 9 years later, then there was the first outbreak of pipino mosaic virus. When that happened, I was working in New Zealand, and we heard about, through intelligence, we heard about the outbreak, and we said, what is this? Nobody knew what it was that. But when the people made the first sequencing, then they realized that it was a minor virus. We say, how in the world it came here? And it's in there when a forensic investigation takes you there, and it can demonstrate that the path through which the virus moved in this particular case. So we realized that we got the pipino there because the geneticists in New Zealand were doing exactly the same. And then we developed a system for monitoring what was the situation in there with the disease. And you can see then that a virus that was in Peru quietly existed in a very diverse population. And all of these are different, isolated from, this is the wild type in Peru, Southern Europe, Germany, Italy, UK, wherever it was found in Europe, including the United States and Canada. And another interesting case is the detection of high-playing virus in New Zealand. When that happened in 2003 or 4, there was only one sequence of high-playing virus in the gene bank. And we were forced to develop primers in a detection system for something that was coming to New Zealand in a couple of weeks. And we made this. And it was detected. And it was interesting. But at that time, through ethnicity analysis, we realized that there was more than one variant. And we were blessed enough because we actually detected it. Now we know, after this article in 2009 from Sapers et al. That was published in Fly Disease, they used different kinds of antibodies, and they collected all the variants in Kansas. And it's interesting to see how they were able to point on the diversity of high-playing virus. And if you consider that we detected with those primers that were published in 2004, only these two variants, regarding all of this, we say, wow, that was an interesting chance of picking something. But chances are that people in biosecurity that is doing this kind of work may miss or may not detect the things. So microbial forensics, again, is a new discipline and is requiring the development of new techniques, and in this kind of methods, the response is critical. That's why I asked you this morning, and you say 3 months, and for I know that if you say 3 months to a government agency, say, okay, see you next year, because they need something now, and it's that way. So the tendency for this kind of research is going to be developing methods that can give quick answers in terms of days or hours. And well, basically what I wanted to point is that biosecurity is not only about bioterrorism, biosafety is not biosecurity. Biodiversity is not only a source of bad guys, and that viruses can be seen probably as an invasive species. Sorry.